Okay, so for today, ladies and gentlemen, we are going to be doing a lab where we are going to figure out the empirical formula of a compound experimentally. So this is just like we talked about yesterday. If we know how many grams of this and how many grams of that we have, and we combine them, we should be able to figure out the formula by taking the grams of one ingredient and the grams of another, converting them into moles, and then finding the ratio between them. Exactly what we were doing yesterday. You don't even have to do the percentages part today. You're going to do it all based on mass. Okay? So, if you would, ladies and gentlemen, get into Canvas. And in Canvas, you need to go to our course. And you need to go to the module section, and you need to find the determination of an empirical formula lab, and open that up right now, please, ladies and gentlemen. That needs to be opened on your computers now. Okay. Now, I will warn you that today in the lab, you are going to be working with concentrated acid, as concentrated as it gets. So if you spill it on your skin, it's going to burn your skin. If you spill it in your eyes, there's a possibility that you could go blind. So goggles are on the back right there. You will wear them the entire time while you are in the lab so that we avoid any instances. Now, the other thing to avoid any instances, ladies and gentlemen, is we are going to handle the chemicals as little as possible. Okay? So the purpose of today's lab is to experimentally determine the empirical formula of a compound containing zinc and chlorine. Now, at your station, there is a balance. At your station, there is a hot plate with an evaporating dish on it, a ceramic dish. At your station, ladies and gentlemen, there are a few other things. There is a bottle of the concentrated acid. There is no reason in the world for you to pick this bottle up and handle it. Okay? No reason. Take the lid off, set it on the side. The lid is not on there tight. Do not try to pick it up by the lid. It will drop, it will break, and it will be a contamination problem. Hold down the bottom. The lid is just set on there loosely. Take it off and set it on the side. You have a container that has some zinc metal in it. And then you have a pipette that you are going to put into the acid. Okay? Now, you need to make observations in this lab that are qualitative and that are quantitative. So let's take a look at our procedure. Mass and evaporating dish. So you are going to take this dish off of your hot plate. You are going to put it on your balance, and you are going to find and record its mass. And that is a little bit further down in the lab, ladies and gentlemen. That is right here, the mass of this dish. Okay? So you don't zero the balance with it on there. You zero the balance, you put it on there, you find the mass of that dish. Questions? Okay, so you're going to find the mass of the dish. Step number 2, you're going to add 1 to 2 grams of zinc metal. That is already massed out in this dish. There is 1 to 2 grams of zinc metal in this dish already done. All you have to do is take the entire amount, dump it into the evaporating dish on the balance, and now find the mass of the dish and the zinc metal that is there. Okay? So you are going to find the mass of both. When you are done with this, you throw it away. Okay? So now you are going to find the dish's new mass, and you are going to record that here, the mass of the dish and the zinc. Okay? Now, there is one more mass that you will be taking later on in the lab, and that is the mass of the dish and the salt, and we will show you when and how to do that. All right. So, next step, ladies and gentlemen. You're going to then take this dish and you are going to place it on your hot plate with the zinc metal in there. You will leave it on there until you are almost done with the lab. Okay? Now, I should mention that before you do this, I should have had this in there, I don't. You need to take 3 observations of the zinc metal. You can touch it if you want. You can smell it. You can look at it. You can feel it. You need to take 3 observations of the hydrochloric acid that is in here. You can look at it. You can smell it. And by the way, I would recommend wafting it. Do not put your nose on top of it and take a big deep breath. Do not touch it. Do not touch it. It is corrosive to the skin. Okay? 3 observations of it. Then you are going to slowly add hydrochloric acid, a few milliliters at a time, until the reaction slows. So let's show you what that will look like, ladies and gentlemen. When you are doing this, you do not pick up the hydrochloric acid off of the bottle. You slide the bottle so that it is next to your hot plate. You then, ladies and gentlemen, have your dish on there with the zinc in it. I'm going to take and I am going to add, a full dropper full of acid to the zinc. Now, you are going to keep adding acid until all the zinc is gone in your dish. All of it. So, right now, it's bubbling, it's moving. Some of the zinc is going away. And it is slowed down on its bubbling. So I'm going to take another dropper full. And I am going to add it. And when I'm adding it, you'll notice I'm squirting it right at the zinc to get it to move around. That will speed up your reaction. Because right now, until this all reacts, you can't do anything else. So again, it's starting to slow down. Add more acid. Now, here is the catch to this part. When you start getting less and less zinc in there, when you don't see it as much in there, then, ladies and gentlemen, you need to add the acid a little bit more slowly. Because eventually I need to boil off all of the extra acid and water that is in there. So the more I put in, the longer it's going to take to boil off. Okay? I don't want that to happen. But again, I still have a ton of zinc in the bottom. You can see it, correct? It's slowing down, so I'm going to have to add another dropper full of the acid. And again, every time I do, I try to squirt it in there to make it spread around, speed up the reaction process. Okay? Now, you are going to also take observations of this reaction as this is happening. What do you hear? What do you see? What do you smell? Don't feel anything. Okay? Don't feel anything. At least 3 observations here. When you get to the point where there is very, very, very little, I mean a few flecks of zinc left in the bottom, then you are going to turn your hot plate up to high. Okay? You're going to turn it up to high. And you are going to keep an eye on it. Now, it is going to take a while for all of this liquid to evaporate, or let me rephrase that, to boil off. So this is going to take you a while when you get to this. Again, I still have all kinds of zinc in the bottom. Yes, it is still reacting, but there's still a long way to go. So I'm going to add another dropper full of acid, keep that process moving along, making my observations, getting ready to go. Now, when I get to the point where there is very little left in here, a few specks here and there, and call me over and I'll say yes, go ahead, or no, you start to turn the hot plate up and you turn it on. But there has to be very little zinc left in here, okay? Now, when you turn the hot plate on, you are going to let it go until it is dry. Now, that's going to take a while. And ladies and gentlemen, you just need to keep an eye on it, because if this starts to boil and things start flying out of your container, then you need to turn the heat down a little bit. Not off, but down a little bit. You want the things to stay in the container, the salt and things that we are creating. You are now creating zinc chloride. And that is what we are going to collect at the end to see if we can determine its formula. Okay? Now, in your instructions, ladies and gentlemen, it tells you that while it is heating, you're going to get less and less water in there. Okay? Now, at the very end, when you are almost out of water, it's going to start to get thick and syrupy in there. Okay? And then what's going to happen is the salt, a white salt, is going to crust over the top of the liquid that is underneath. Now, the liquid underneath will be boiling. So what will happen is that salt will literally start to move up and down in your container as the liquid underneath boils off underneath it. You need to pay very close attention now, because as soon as that salt stops moving up and down and it just sits in the bottom of your dish, you need to take your tongs and move that dish off of the hot plate onto your counter. Take it off of your hot plate and put it on your counter. And you turn off your hot plate. So when you get to the point where it's getting really syrupy, raise your hand, call me over, and I'll come over and I will help guide you through this. But when it stops moving, this white crusty salt, you have to immediately grab it with your tongs and set it on the counter and turn off your hot plate, because now your experiment is over. Okay? Now, we need to let it cool down because we have to take one more mass. Okay? Now, the rule for taking this last mass, and by the way, the acid will be gone. This will be safe. Okay? The rule for this last mass is you check to see if your dish is hot. If it is cool enough that you can put it in the palm of your hand, then you can put it on my balance. If it is not cool enough for you to pick up and put in the palm of your hand, don't put it on the balance. It is too hot for it. You will bend the metal plate in the bottom. Okay? So it is better to let it cool too long than not long enough. While it is cooling, you can turn off your hot plate. You can wipe up the top of your hot plate. As soon as you are done with the acid, I will come over and I will collect it from your station and get it out of there so no one can get hurt by it. Okay? We will throw out the pipette in the garbage. And now you are going to make your last observations of the white solid that is in that container, and that is the dry salt at the end. That is this right here. Okay? So when it is over, you can make these observations. But you need to wait to put it on the balance until it is cool enough that you could set it in the palm of your hand. Okay? Questions? Now, I have more stations set up than we need, ladies and gentlemen. Here is the other thing. this lab gets really smelly. Really smelly. You remember the one we did in the first try where we made the yellow gas and you guys were all choking on it? This is worse. This is worse. So you need to work with a partner because there's going to be a point where you or your partner is going to be like, I can't take it anymore. I got to go get a breath of fresh air. And the only way you can do it is to walk out in the hallway. Now, if you walk out in the hallway, your partner needs to stay and watch the experiment. And then when you come back, your partner can go get a breath of fresh air in the hallway. But you cannot both leave your experiment. So you're working with somebody. I would recommend wearing aprons in the back of the room because if the acid gets on your clothing, it will make a hole in it when you go to wash them. Do not handle the acid any more than you have to. All you have to do with it is take and put it into the tray, the dish that is already on your hot plate. By the way, this is not doing anything anymore, and there is still a bunch of silver in the bottom. So I need to add more acid to this to get that reaction to the point where all of the silver is gone. Okay? So even now, there's hardly anything going on. I would add more acid to it. Get it moving, get it going, get it along, because then once you start heating it, that's the last part of the experiment. Questions? Do you see the smoke and things rising off of here? No? Maybe you can with the white background. It might be hard to tell. But it's going to get smelly in here. Questions? Goggles are over there, or goggles are there, aprons are there. Let's go. Let's get to work, ladies and gentlemen. Right now, you will not need calculators. What kind of charger is it?
Go to the main office and go to the bathroom.
And go to the where? Or turn it in student services, I believe. And then have them write a pass to you to go wherever you need to. See you, Cameron. The element. What element? No. Zinc is what you started with. Okay? So, let's take and let's look at this real quick here, ladies and gentlemen. So you started with zinc in your container, correct? Okay. What did we add to the zinc in your container? What was the chemical? What was the liquid? What was the acid? What was it? Hydrochloric acid. Okay, so this, ladies and gentlemen, is the start of our reaction. What kind of reaction is this setting up to be? Think about last unit. No. Synthesis, decomposition, single replacement, double replacement. This is setting up to be a single replacement, which means, ladies and gentlemen, that the zinc is going to go and replace the hydrogen in this compound. Now, zinc has what charge? +2. Chlorine has what charge? So what should a compound of zinc chloride look like? ZnCl2. And this, ladies and gentlemen, was aqueous. Aqueous means it was what? In water. So what would be the other compound that is created here? So if the zinc goes in and replaces the hydrogen, what's the other element that is created here? Come on, guys, single replacement reaction. The zinc goes in and replaces something. It's now in the compound. What's the lone element? Hydrogen. Okay? Now, how do we write hydrogen in a formula or in an equation like this when it's alone? H2. Remember, it is a diatomic. H2. And by the way, what state of matter is it? It's a gas. It's the stuff that was bubbling out of there as you were doing the experiment. Okay? All right. So, this right here, ladies and gentlemen, this is the salt. Now, originally it was dissolved in water, but then what did we do to the water? We boiled it away. So we got this salt out of our reaction. Okay? That is what we got out of our reaction. All right? So, that is the salt that is in there. So, to find the mass of the zinc, you take the mass of the dish and the zinc minus the mass of the dish. These first two, you should be able to calculate the mass of zinc. That number then comes down into this formula here, the mass of the zinc. Now, to go from mass, what unit is mass going to be in, ladies and gentlemen? What unit? Grams. So, if I want to go from grams to moles, I use what mass? Zinc's what? What do we call it though? We use the formula mass, just like we were doing yesterday, off of the periodic table, correct? But which goes on top here and which goes on the bottom? Does mole go on top or does mole go on the bottom? Does formula mass go on top or formula mass go on the bottom? What goes where? Mole goes on top, formula mass on the bottom. So you could take out where it says 1 molar formula mass. You could leave 1 mole on top. You could take this all out and put the formula mass on the bottom. Do the math. Tell me how much we get. Now, it should be a very small number. Because if you think about it, what's the formula mass of zinc? Okay, and we had about 1.6, 1.7 grams in there. That's going to be a fairly small number. Don't be surprised by that, okay? All right? Now, next, we're going to find the mass of the substance in the evaporating dish at the end. So we are going to take the mass of the dish and the substance, that's salt, the very third one, minus the mass of the dish. So we get just the mass of the salt in this case. Any questions on that? Okay. So then next, we know that substance is zinc chloride. So we need to find the mass of the chlorine that reacted with the mass of the zinc. So the way we are going to do that, we are going to take the mass of the substance that we got in number 3 minus the mass of the zinc that we got earlier. Because if that compound is zinc chloride, and we know how much zinc is in there, the extra mass came from the chlorine that is combined with it. Does that make sense? Okay, a couple of you are nodding your head, so I'll accept that. So you're going to take and find the mass of the chlorine by taking the mass of the substance minus the mass of the zinc. When you get that mass of chlorine, ladies and gentlemen, now you are going to put it in here, and we're going to use 1 mole and formula mass for chlorine to figure out how many moles of chlorine reacted. Now, again, what goes on top, what goes on the bottom to go from grams to moles? Mole on top, formula mass of chlorine on the bottom. Okay? Formula mass of chlorine on the bottom. So this is just what we were doing yesterday in class. Taking the mass of the element and getting it into moles. Taking the mass of the element and getting it into moles. Now, to find the empirical formula, you have to take the moles of zinc and the moles of chlorine and divide them by the smaller amount. Whichever one is the smaller number. Is it the moles of zinc or is it the moles of chlorine? You divide them both by whichever number is smaller. And that, ladies and gentlemen, will get you a ratio. 1 to something. Now, what's the formula of zinc chloride supposed to be? ZnCl2. So there should be 1 zinc and how many chlorines? 2. Should be 2. That's what you should get. I'm not guaranteeing that's what you got, but that's what you should get. And if you did the lab correctly, those are the numbers that you should get. Around 1. Well, you're going to get 1 for sure, and around 2. Maybe 1.99, maybe 2.01, something like that. But you should be very close to these numbers. Okay? Now, tomorrow in class, we will take a look at the 3 questions and the conclusion that you need to write. Do we need to write a conclusion here? No. We just will look at those 3 questions. Have a great day, ladies and gentlemen. We will see you tomorrow.